Hello, welcome. Good morning or good afternoon, depending where you're dialing in from, and welcome to this KuppingerCole webinar. Today it's supported by GitGuardian. I'll be joined by Mackenzie Jackson later on, who is a developer advocate for GitGuardian. And we're going to be talking a lot about DevSecOps or DevOps and a maturity model for secrets management. Secrets management is something that you've probably been hearing a lot about recently. So before we get started, just a few housekeeping tips. You don't need to do anything to mute yourself. That's all done for you. There will be two polls during the webinar, which we will then discuss the results during the Q&A. And indeed, we'll take questions from the audience at the same time. Also, we are recording this whole webinar, so if you have a colleague that can't make the live event and wish to pass it on, then they can do, and obviously you can visit the webinar yourself. So that's all to come. So here's the agenda. So I'll start. First up, I'll be talking a little bit about DevOps and the business culture that we currently see. Then Mackenzie will be talking in more detail about secrets management and with particular relevance to DevOps and of course GitGuardian. And then we'll have the Q&A session. So let's get going. Let's talk a little bit about cultures. But before we do that, let's have the first poll, which is, what do you think is the biggest challenge to security in a multi-cloud environment? So we have answer: credentials, secrets, or data left unprotected in the cloud, no control over privileged accounts with access to the cloud, or poor cloud architecture design and a lack of network hygiene. So we'll start the vote now and just give you a few, like 30 seconds or so to vote. I just noticed that we so impressed with that question that we've added an extra question mark on it there. So that's good. That one slipped through the Q&A. Sorry, not the Q&A, the QA. So number one, the credentials are secrets. 2, no control over privileged accounts. Or 3, poor cloud architecture design. So I'll just leave that running a little bit longer. Okay, I think we've now got enough results in for that. So let's move into the main part of this part of the webinar. So what do businesses want? We often talk about technologies, KuppingerCole, we talk about emerging technologies, we talk about infrastructure, etc. But we don't always think about the business. So let's have just a quick look at what businesses want. So obviously they want to be agile. Agile is possibly an overused word, but it's still a relevant word. The more quickly that things can happen, the more things can be changed or fixed, the better it is. So we've seen the emergence of agile philosophy or agile scrum, things like that. But that leads to, the goal of that is obviously to have a rapid rollout of services and products. The competitive landscape in virtually every sector is such that you can't afford to be behind your competitors when it comes to products, but that's works on the inside as well. We're not just talking about what the business does for its customers. Obviously that's the paramount important, but also what happens inside the business and inside the organization. So improving those infrastructures through, quite often these days, digital transformation or digital initiatives, or moving stuff to the cloud, etc. And in an age of inflation, in an age of supply squeezes, in an age of uncertainty, in fact, let's face it, we do live in a turbulent time at the moment across the world. So anything that can reduce costs, reduce reliance on unreliable suppliers, etc., is also what the business wants. Productivity, again, is a word a lot of people will be using. Politicians use it to describe what the gross output is or isn't really of a nation. But productivity is also relevant on a micro basis. So any business that can increase output and productivity is going to also be at an advantage. And finally, behind all of that, one of the positive and obviously also one of the demands of digital business culture is the amount of data that is produced. But increasingly, companies see that as a source of intelligence and a source of better ways of refining product, better ways of working, better understanding of the customers. So that's essentially, there's 6 key things that the businesses are looking for in today's environments. So let's now get a bit more in focus with what we're kind of talking about. Key to all of that, it has to be said, are coders, programmers, developers. This is a quote from an excellent book written by Clive Thompson called Coders, in fact, published a couple of years ago, which captures the essence of the kind of people and the kind of culture that exists within them, and how the way they work is having an impact on the way businesses operate. And it's not always a mutually beneficial relationship at the moment, because the two working towards the same goal, but not necessarily in the same path. So developers, and that is the book I was telling you about there, the cover there. The developers tend to work extremely hard. They're very, very target focused. They, more than anyone, are cloud native, cloud savvy. They can work in multiple cloud environments, right from birth, as it were. Coders are in a multi-cloud environment. They use tools such as MongoDB, for example, which is a cloud-based database tool for application development. And they love automation, they love speed. Anything that can make their job quicker but more accurate is also essential to them. They, even more so after the pandemic, more coders are now working in remote places, and that can be all sorts of places, not just necessarily the stereotypical hotel room or coffee restaurant, but also obviously at home, obviously in even abroad, etc. They are not afraid of open source. They're not afraid to try new things there, obviously, which is relevant again to what Mackenzie will be talking about. But they use tools like Slack and GitHub, etc., to get stuff done. And they this is key. They're very into collaboration and sharing, which again is a good and a bad thing. Collaboration and sharing between coders actually encourages innovation, encourages ways to find solutions to problems, but it can lead to sometimes things being overshared or things being left behind which shouldn't be left behind. But ultimately, coders are problem solvers. They're there. The problem the business has is to develop an application to do a certain thing, and coders are increasingly the people that are the ones that are going to provide that solution. So the point is that developer culture and coders are hugely important now to more and more organizations, even those organizations that once perhaps were considered more static, such as financial services or insurance services and things like that. Even in places like health, coders are now becoming more relevant, and the pace of change and what the businesses want is all leading to a much more dynamic environment everywhere. So we used to call about a few years ago the term DevOps came into use. It's sometimes known as DevSecOps, but the key is that people started thinking, we need to secure these guys, these DevOps guys. It was a great idea bringing developers and operations together, but they seem to be now a law unto themselves, which they weren't. I think that was a bit unfair because, as I said, what they were ever, I don't think DevOps developers actively saw themselves as a law unto themselves, but they like to get things done. And sometimes this meant they didn't follow the traditional security rulebook. But what happened to SecDevOps? Did it actually improve security? Did it improve productivity? Where in all this were the traditional identity management tools such as IAM, privilege access management, and more latterly, cloud infrastructure entitlement management? Was it sustainable to have yet another sort of department of security or IT security that was specifically designed to look after developers? I would argue personally that it's not really a sustainable practice. The idea that you can keep up with the speed of developers with tools which are branded SecDevOps or are just sort of add-ons to existing applications. I really think that was probably a non-starter, and I think that we're now moving to a different age, which we shall also be discussing. So that means that developers effectively are unleashed. We should give them as much freedom as is possible, as much room, as much dynamism, so they can deliver the stuff that we expect them to. But we need to know how to protect them. It's not so much that they, as I said, are willingly seeking to break the rules or damage the business. It should be perhaps the other way around, so that we can enable them to be efficient and be productive and deliver the tools. But we need to protect them, not the other way around, if you see what I mean. If we protect them, we protect the business. So what can we learn from them? I mean, like I said, they are the technological cultural leaders in the way that they do stuff, and they innovate amongst themselves. And we can certainly learn from when we're building access management tools, how we can certainly learn from them some lessons in how to make things more innovative, but also more dynamic, closer, much closer to where the operations are actually happening. So let's take a quick pause and run our next poll, which cloud platform do you mainly use for your digital transformation? And if you just select one, the choices are pretty obvious, I guess: AWS, Azure, Google Cloud, IBM, or any other. I imagine most people on this call will use a cloud of some form or another, but we're just interested to see who is more popular. So they're either AWS, Azure, GCP, IBM, and others. And I guess it's important because Microsoft certainly is developing in cloud infrastructure entitlement management tools specifically for Azure and Azure Active Directory. So there is a kind of arms race going on between AWS, Azure, and Google in providing the more secure and more efficient access tools. So let's look at how identities might flow, in a typical organization. So what we have here is identity flow, and this one I've highlighted cloud infrastructure entitlement management as the particular tool here for allowing identities flow through the business. So the core business infrastructure, as it shows there, extends obviously the developers or the end users or machine identities, etc., or obviously at some point enter the core business infrastructure either through an endpoint or through a workstation, etc. And then they possibly now would use a privilege access management tool if the developer has a privilege account. More likely, they now might be using cloud infrastructure entitlement management tools or the proprietary tools that come with AWS or Azure or Google Cloud. All three have their own versions of some form of access management. But what the developers specifically want to get to is more cloud services. They need to access platform as a service, software as a service, all sorts of tools, infrastructure, and of course, private clouds. And that's where the bottlenecks can happen, which is where we need more dynamic entitlement, particularly when they might be accessing private clouds, which are still kept on premises. To get to what Mackenzie will be talking about, this is where your secrets management piece really comes into play. And this is where the secrets management piece that we need to see become more common needs to be as friction-free, as close to those developers as possible, so they can actually get to the resources such as the files, servers, workloads, containers, etc. So once again, we see it's always everything in modern organizations, modern infrastructure is about matching identities with resources. And it's how we get them together is the important bit in the middle. So identity management or cloud management, secrets management is something that we need to adapt to the ways of developers working, coders working. We need to move away a little bit, I think, from the more traditional view that security was everyone's responsibility in a business, so that everyone went around with the mantra that, you know, we shall stop all phishing attacks, we shall never do this, and we are very security aware. I perhaps controversially, some suggest that we should actually get back to a position where the IT security platforms, the cybersecurity platforms, access management platforms, secrets management, look after the security, are smart enough or automated enough to do the security management that enables the doers, the coders, the employees, the partners, everyone to do the job they want to do, rather than being lumbered with this sort of extra responsibility. We need to start thinking about, do we need to move away from monolithic platforms? Traditionally, privilege access management, identity and access management have always been pretty big centralized platforms which sort of work bottom up and sideways to manage identities from across the infrastructure. The problem with that is that those platforms were traditionally deployed, managed by CIOs or CISO teams, not necessarily directly by those offices. And those teams, the developers particularly, are starting to move away from that zone of influence because of things like the speed and the ease in which end users, developers can spin up cloud resources, can spin up a virtual machine, can spin up things like Windows 365 pretty easily. And there's absolutely no way that a CIO or a CISO or their team can see that. on a daily basis, let alone as it happens. We need to think more about zero trust. I had put zero trust there, but we need to, like, there's an adaptation of zero trust, which goes into, if we verify and entitle and secure at the start of any identity workflow, we don't need to worry about their responsibilities when it comes to security awareness, etc. So those are sort of 4 areas in which I think identity management, I put identity management, but it's secrets management, it's privilege access management as well, but we have to adapt these tools. So just to wrap up my part of the webinar, there's just 3 things to think about when you're thinking about secrets management, not just for DevOps, but really for any part of your business. Start thinking about allowing autonomy. Except there will be new centers of control, not centers of security, but centers of control. Think about what I call zero distance identity and access management. So the control is right next to the access point. So we're talking about decentralized identity. Think about embracing infrastructure as a service and operations automation. The piece of DevOps, the ops part, is becoming increasingly unimportant, I think, and DevOps is operations. And much of automation, much of ops is being automated, and the more you can automate, you will take away those workflow chores. And start thinking about what we at KuppingerCole have classified as dynamic resource entitlement access management, along with cloud infrastructure entitlement management solutions, which includes some PAM solutions, but also some newer solutions. There is actually a leadership compass, which was recently published on that theme. So there are vendors out there which are understanding this new environment, and that well worth reading about in that report. So with that, I'll hand back now to, or rather, I'll introduce you to Mackenzie, and I shall see you in a little while.
Well, thank you so much for that. I believe, well, hopefully you can all hear me. I'm sure someone will say something if you can't, and you can see my screen. Yeah, I want to kind of continue on a little bit from what Paul was saying, and we're going to go through a DevSecOps security model for secrets management, and we'll discuss exactly what that means throughout the presentation. But essentially, what it looks like to be an organization with a high level of maturity when it comes to handling, what we call secret sensitive information. So just a quick overview. I'm going to go through quite quickly. I've got a lot to cover, so I'll go fairly quickly, but just so you know that everything that we're going through is outlined in reports that we have that I believe you'll have access to too. So we'll go through the problem of hard-coded secrets, exactly what they are. Then we'll actually kind of, I'll try and scare you all a little bit by talking about some high-profile breaches. So I think it's always good to relate conceptual ideas and models and maturity to what happens in reality when those fail. So we'll talk about some recent high-profile breaches that have happened as a result of poor secrets management. We'll talk about unsecured development practices, the maturity model that GitGuardian has put together of what we believe companies should strive for in secrets management, in automated detection and remediation. And then I believe we'll go into some Q&As where you'll have an opportunity to ask me some very difficult questions. So let's start with the problem of hard-coded secrets. I like to get everyone onto the same page when I'm using the term secrets of just exactly what I mean when I'm talking about secrets. So I'm talking about what we call digital authentication credentials, and these can really be anything that authenticates us or unencrypts or gives us access to systems, databases, services. So typically these will be things like your API keys to connect to third-party services. It may be security certificates. It may be encryption keys. It can be just credential pairs, username and passwords. to things like databases or to services, browser session tokens, and much more. So really, you can get the idea of this is essentially going to authenticate, going to give access to, to potential malicious actors or to yourself access to the services that you use. So very quickly, GitGuardian does a lot of research into how much of these secrets actually get exposed in the wild. So one of the places that we look is GitHub. So GitHub is a tool that nearly every developer will be using in their arsenal. They've got 80 million developers, more than 80 million developers on GitHub. And it's really a code sharing platform. It's the largest space to share open source tools and repositories and code. And developers often use this as a portfolio. It's unavoidable to kind of have some form of coverage with GitHub as a developer. So what actually GitGuardian does is we scan every single public activity on GitHub. So every time you commit, if you're not familiar with the word commit, you can think of it like upload. Every time a developer commits code publicly to GitHub, GitGuardian will scan it. To get an idea of the volume, there was 1 billion commits last year by 56 million developers. So I said that there's 80 million on GitHub. The difference here is that not all of them pushed code actively publicly last year, but 56 million of them did. So huge numbers. So how many secrets did we actually find? Well, we found 6 million secrets publicly. So this is out in the open, no authentication, not behind any layers, sitting out in the public. We found 6 million credentials here. So huge problem. You don't, as an attacker, it gives you a lot of options as to what to do. Now, these range in severity, but I can tell you that 15% of them were for cloud providers. So 15%, over 1 million secrets for cloud providers, which even if it's personal, is still highly problematic and you can do a lot of damage, were leaked last year publicly on GitHub. So let's talk about some high-profile incidents now of what's actually happened when these secrets find their way out into the wild. So the first one I want to talk about is CodeCov. I won't go into too much detail about what CodeCov is, but it's a tool that essentially helps you test your application. It tests how much of your application is being tested. So it does a very specific job, and it sits in the CI/CD pipeline in your software delivery process. So what actually happened? So CodeCov ships their product often by a Docker image. A Docker image is basically just a collection, a snapshot of an application and everything it needs to run. So organizations take this Docker image, they plug it into their services to run CodeCov. This Docker image was publicly accessible to everyone. It was stored on Docker Hub. An adversary decided to investigate this Docker image, and they found that actually there was a plain text credential in there. There was a hard-coded secret. Anyone could have found this had they known how to kind of dissect this image, but it's really not that difficult. What this credential gave access to is it gave read-write access to some files that CodeCov were hosting, and this allowed the attackers to actually inject a malicious line of code into a script that they had, a bash script that 20,000 customers were actually using. So 20,000 organizations were using this version of CodeCov. What that script actually did, that malicious line of code actually did, it was buried very well. It'd be very hard to notice it if you were perusing this document, which had over 2,000 lines of code in it. And what the script did is it said, when an organization uses CodeCov in that testing environment, capture all the credentials that are being used by that application in the environment, so all the secrets, and I want you to send them remotely to this address, to the attacker's address. So every time a customer ran or a user of CodeCov ran that application, it stole the credentials and sent them to the attacker. The main credential that an attacker was after was access to internal version control systems, internal Git repositories, namely. So what we know is that a lot of large companies that were using CodeCov actually had their internal version control systems accessed by this malicious actor. And some of these companies, HashiCorp, Twilio, Rapid7, Monday.com, were all affected by this. So an attacker found a hard-coded credential in a Docker image. They used this to inject some malicious code. And from that, they were able to move laterally into different organizations where they were able to access internal repositories. And in all the companies I just named, HashiCorp, Rapid7, Twilio, there was actually additional secrets in their internal version control systems. So pretty bad scenario here. As I said, 20,000 users were affected by this. So this is one example of a secret entering out into the wild, in this case through a deployment process. Another very recent one happened a couple of weeks ago, which is Uber. You may have heard that Uber suffered a very significant data breach. This one was actually incredibly bad, but luckily for Uber, the adversaries that actually did this, it appears that they were more after making lots of noise than they were of actually achieving malicious goals. But it could have been extremely bad. But what exactly happened? Well, a contractor for Uber, an EXE contractor, had their credentials stolen and put on the black market. I'm not exactly sure the process that happened, but essentially you can buy all kinds of credentials to organizations on the black market. Could have been through a different breach, could have been through phishing, but we can assume that one of these reasons was how this contractor had their credentials put on the black market. The attacker then tried to access Uber's internal network via a VPN with these credentials, but were blocked to a multi-factor authentication. So the attack could have stopped there. However, the attacker in this case applied some social engineering to get that contractor to accept the multi-factor authentication request. Exactly how they did this, I'm not sure, but it could have been a phone call of the attacker claiming to be from the security team and that they needed to accept this because they needed access to the account. However it happened, the attacker was then able to gain access into Uber's internal network. Now, just because they have access to the internal network doesn't mean that they can do horrible things. It's not good, and it's certainly, very, very critical. But this was elevated to a whole nother level thanks to some hard-coded secrets that were lying around in Uber's internal network. So they started scanning documents and files, enumerating through all this different data, and they found some PowerShell scripts. So PowerShell scripts are used for various methods of automation. So, but inside one of these PowerShell scripts, there was a hard-coded credential for the Privileged Access Management System, the PAM system. And this was an admin credential for the PAM system. So the Privileged Access Management System, this is what controls basically access to to different third-party activities. It stores your secrets. Admin access to this is worst case scenario. It's basically your password manager and your secrets manager combined, and the attacker will then basically had access to everything. So they moved laterally from the PAM system, which happened to be Thycotic, into AWS, GCP, Google Suite, Slack, Sentinel-1, HackerOne, and that's what we know of. And at that point, the attacker then started making a lot of noise, posting in Slack channels internally to say that Uber had been hacked. So what we can see here is that there was hard-coded credentials in this PowerShell script. Why they were there? Well, it was admin access to a PAM user, so probably they were automating some processes of adding users. But because of that, worst case scenario, an attacker got access to basically everything. Had they been malicious, it could have been much worse, but it appears the goal was to make more noise and get publicity more than anything. So unsecured software development practices. So we're really building software at a rapid pace now. And there are a couple of things that have really caused and enhanced some insecure practices that have been in place for a long time that are really being exposed now. So number one is that we're adopting CI/CD pipelines. We're adopting Devops practices. And this has accelerated software development to a point where it's gone past what we can manage from the security point of view. Deployments are happening daily in large companies. There is so many tools that have automated processes. From a developer can control the entire deployment process from code now. So we're codifying all these different steps, but those coding practices haven't become more secure. Paul touched on, the monolithic application. So we truly are moving away from this. And I always like to use the example of all the different third parties tools that we use today. Credit card processing is the easy one to talk about. Are you going to build your own credit card processing, or are you going to implement a company that does this already, Stripe, PayPal, right? You're going to implement a company unless that's the core thing that you want to do. But this is extrapolated to everything now. Managed databases. Maybe we're going to implement search. So we're going to use Algolia. Maybe we don't want to write our own authentication, so we'll use Okta or Auth0. Number of different tools. And these are all kind of used by developers. But then when we go to the DevOps team, they have their own tools. We've got cloud infrastructure. Are you going to build your own servers and host your application, or are you going to put it on AWS? Are you going to create a version control system? You're going to use Git. All these different areas. And we can extrapolate this more into microservices and tools that sales and marketing use as well. The key point here is that all of these different tools are external, and they all leverage secrets, right? We have to authenticate ourselves. Every single one of these tools is a potential access point for an attacker. Now, that tool may not be critical, but as we saw with Uber, you get access to the internal network, you get access to the internal repository, you get access to the internal messaging system, then you're probably going to be able to find additional sensitive information to move laterally. So we're really accelerating the rapid pace of code, but we're also introducing another level of vulnerabilities in our applications. So why do secrets get exposed? Well, the number one reason, I could skip past this whole slide and then I could just say basically human error, but we can go a little bit deeper. You can imagine a scenario, a developer is quickly trying to get something to work. He hard codes a credential, he or she hard codes a credential. They commit that. Even if they do the right thing, even if they remove that credential, even if they use environment variables or whatever else we're using, and by the time that goes to code review, there's no sign of anything trouble. Well, source code is a vulnerability in itself because it keeps the entire history. You do something a year ago, there's a record of that. You hard code a credential on a development branch 500 commits ago, it's still there in the history. It's very hard to delete, especially if you're working in teams. And attackers know this, which is why they're doing it. So, that's one area. This is particularly true when a repository is made public, right? We deal with a lot of open source. Companies are regularly maintaining open source projects. These often start as internal projects that the company decides to make public for various reasons. Perhaps they don't have the budget to maintain that themselves, so they open source it. But had they done something a year ago in the safety of a private network, well, now they've open sourced it. They've long forgotten about that hard-coded credential, but now it's public. Logs and generated files are another way. You could be doing everything right, but if you come across a problem as a software developer, as an engineer, you're going to probably produce a debug log so you can figure out where it's went wrong. Guess what's in that debug log? Environment variables, different kinds of secrets. If that gets version controlled, if that gets put in a network somewhere and forgotten about, then that exposes your secrets too. We have sensitive files as well. And we also see a lot of people accidentally pushing things to the wrong areas. On GitHub, if you use it personally and professionally, you actually have the same account. It just sends it to different areas. Makes it really easy to make a mistake and send something to your personal account that was meant to be on a secure network. So what does it look like to have a mature model of managing secrets, a DevSecOps security model? Well, just to emphasize a little bit of the problem that we're actually facing here, I'm going to devolve from public spaces and I'm going to start talking about internal spaces now. So if we take a medium-sized company that has an average of 400 developers, so what we see when GitGuardian will investigate the internal networks and code of companies, a company around about 400 developers will typically have about 1,000 secrets sprawled across their networks and inside their source code in particular. These 1,000 secrets will occur in an average of 13 different places. Total, 13,000 secrets. That same company probably has 4 AppSec engineers. So now let's talk about if this company is magically able to get visibility to locate all of these secrets, you now have 4 people that have to deal with 13,000 secrets. That's 3,400 secrets each. You do 10 a day for a year. You don't take any holidays, and that's all that you do, and you may get there. But this is the problem, and we can't rely on any one person to stop it. we have to stop this throughout the entire software supply chain. So this is just kind of an idea of why we really need to have maturity in secrets management, because the problem's huge. And even if you can uncover that you actually have a problem, which is kind of like level 3, you're aware of your problem, it's already a little bit late. So I'm going to go through 4 levels that we've come up with that we believe will give you good maturity in handling secrets. So I'll go through each one of these levels and what it involves now. But first, before I do that, I just want to say, that when we're talking about this, of course, everyone should be at level 4, right? We should have a fantastic security model. But you can't go from 0.1 to level 0 or level 1 to level 4 immediately. There's no silver bullet. A lot of security vendors will say that their product solves the issue, and then tomorrow you implement it, and then you're fantastic, you're set. The reality that we all know that work in this space is that vendors provide tools, but not complete entire solutions to massive problems. And it's a journey that you need to get there. So tomorrow you implement some great tools, you uncover that you have 13,000 secrets in your network. Well, we need to go through a series of processes to actually get to level 4, and we need to have a plan to get there. Throwing money at the problem doesn't completely solve it, right? We need tools to help us in various ways, but there isn't a silver bullet to this, and doesn't matter how much money you throw at it, if you don't have that plan in place, you won't get there. So what's level 0? You'll be amazed at how many companies are here. And this is basically that speed is more important than security. We manage all our secrets kind of in an unsecure way because it gives all the developers access to them. It gives all the DevOps guys access to them quickly. We don't publish them publicly, but they're lying around everywhere. This is basically where a lot of companies are at, not even understanding, how easily these are accessible. And the argument may be that their source code is private, therefore it's not an issue. But I mean, these are the most sensitive items that we have. If you're anywhere but a tiny company, you'll have tens and hundreds of developers that have access to this. You're basically giving them access to your credit cards, giving all those people access to everything, not to mention the fact that security breaches are more and more common. Level 1 is when we're starting to see an understanding of this. It's basically means that secrets are still stored on developers' machines in unencrypted ways, so configuration files, but it means that they're not purposely hard-coded in there. But maybe you have an environment variable file that you store in plain text. And in our source control, we have these secrets grouped, so maybe we have a little bit more understanding of where they are, but essentially, we're still, they're still in plain text, they're still distributed. And important to know that if something gets into your version control system in your source code, it's going to be backed up into multiple different areas. It's going to be on different developers' machines. It's going to be in wikis. You're going to lose track of it. Now, you also notice there's some kind of grayed out areas there. We have a report on this that you can go into. It has much more granular details. But for the sake of this presentation and the time, I'm just going to focus on the developer environments in the source code. But in the report that you'll have access to, you'll be able to go further into these different areas that we talk about as well. But as we get through some more intermediate levels on here, you might start storing your secrets in appropriate places. For instance, let's say you implement a vault. HashiCorp Vault is one that often comes up, and you're sharing them through a secrets manager. But developers still have access to them, and what is critical is you may have policies in place, but you have no idea of whether those policies are being followed, right? You have a tool, you have a secrets manager, that's great. And you have some idea of how that should be used, but is it being used that way by your developers? Do you know? And then over on the secrets detection side, you may have some manual detection for these secrets, but it's not sophisticated enough that it's going to catch everything. And then in our source control, we'll see that perhaps these are encrypted, but they're checked into our repositories. But just because your secrets are encrypted, doesn't give you a high level of maturity. because that encrypted file is distributed everywhere, and you've given yourself a single point of failure that just requires a secret to be leaked. And if you don't have, high levels of maturity in managing secrets yet, the idea of having one single secret that will unlock everything quickly is certainly not a great practice. And in terms of secrets detection, you might have some areas that are continuously scanned at different stages, but you don't have that continuous scan over your entire environment. You still don't have visibility as to whether or not your policies that you created are being followed. So level 3, this is the first level where you're not completely screwed. I would say level 0 to 2 is really you're at an extremely high risk of exposing sensitive information. And that is because you don't have clear visibility over whether the policies are being in place and whether the tools are being used correctly. You have some ideas of how to do it, but level 3 is now where you actually start syncing together some visibility, some tools, and what's a really important thing here is some remediation. So in this, at level 3, then you have your secrets stored in vaults, and you're only sharing these with your developers through appropriate secrets managers. And here's what's really important. You have rotation policies in place. What this means is that if secrets do get exposed in history that are dated, that you're rotating them regularly enough so that they don't pose an active threat. And also in the development and things, you now started to implement scanning at different stages of the software development lifecycle, not just on your networks, not just on your source code in the server, but actually on the developer's machine. Why that's important is it's going to prevent breaches from happening. If a secret reaches the version control system, it's already game over. But having it on the system means that we can stop the bleeding so much. And we no longer have secrets in our source code, but here's what's key in that secrets detection stance. We're continuously monitoring for hard-coded credentials and stuff on all of our repositories. So this is actually giving us some insights, and we've just started to implement some remediation policies that bring together different teams. And finally, this is the level that we all should be going to. I'm just going to point out kind of what's the key differences between this and level 3. There's number 1, we have dynamic secrets. This is the idea of just in time. Secrets are being created and destroyed just for the lifetime of the purpose that they're being used for. So that means if they get exposed, they're immediately redundant. And in terms of that secrets detection stage, what we have is remediation that's automated that involves everyone. I'm going to talk very quickly about remediation and why that's important soon. But this is really the kind of the difference between being that expert level and still having a developing area, is that things should be automated, they should cover everything, and they should involve multiple teams. And we're, and automated in the creation of secrets, automated in the rotation of secrets as well. So this is what we really should be aiming for. So how do we build this effective program? Well, an effective detection and remediation program for secrets will include monitoring, detection, alerting, remediation, and analytics. And all of these are important. Yes, we need to be able to detect secrets, but we also need to make sure the alerts are going to the right people and that the remediation process is set up. We go back to those 3,000 secrets that every AppSec engineer has to do. Well, we need to make sure that remediation is spread across different people so that that becomes actually a manageable task. And analytics is really important so that we can get visibility into where the problem is, right? What teams are leaking the most amount of secrets, what projects we need to focus on, what systems are most vulnerable, how long are secrets valid for. All of this we need in our tooling. So GitGuardian has a kind of, is one way of accessing that, getting that visibility into your systems, making sure that you can detect secrets, finding out are secrets valid, what teams, where they're coming from. So that's one way, and that's critical of getting visibility into your systems so that when you do implement systems like vaults and you do implement policies around that, you can actually check that they're being followed up on and the remediation processes are being automated. And we need to make sure that we have detection in multiple stages. I touched a little bit on this. Scanning just your server isn't good enough because the threats are already active. We need to define them before on the developer side in your local environment. And we also need to detect them when we deploy applications. So in the case of CodeCov way back, secret was in a Docker application. That was part of the deployment process. Maybe that secret skipped all of those stages and just revealed itself at the deployment stage. So it's, you could have detection on all your developers' machines. You can have detection before they reach your server. They could have detection on your server. But secrets can expose themselves in every single step of the way. So you need to have detection at every single step of the way. And on that local environment side, that's where you're going to make it manageable, because that's where you're going to stop the bleeding. So, we've talked about DevSecOps. I know Paul talked about DevSecOps. I'm nearly finished, but this is often thrown around, by people. But we actually need all these teams to work together. And in secrets detection, and having a mature model of managing secrets will involve all of these teams, because security teams will be able to see that the policies they're created are being enforced. DevOps and SRE teams will be able to implement automated detection so that when something happens, they know about it, security knows about it, and then developers can actually help in this process with literally shifting security left. Shift left is the key word everyone likes to use, because they're involved. If a developer leaks a secret, then they need to be part of the remediation process, because they're the ones that know what it does. So here's an example of that. If a developer hard codes a credential to something, it gets into your version control system. Security team gets an alert. The developer will automatically get a survey to make sure that they can alert, is the secret valid? What was it for? Who leaked it? All that information, so that security actually has that at their fingertips. That's what mature remediation looks like. It involves everyone. Everything's automated, and everyone's providing information so that the decision makers that need to take action have everything at their hands. So concluding notes, my last slide is that, secrets management is of three core pillars: processes, people, and tools. So processes is being able to create policies, being able to know what to do when we have breaches. People, we need to train people. We need to raise awareness of this. And of course, we need the tools to help remediate, to help automate, and to help solve this problem. But as I said at the start, there's no silver bullet. All three of these need to be followed if you're going to reach that level 4 maturity. And with that, I'm open to the Q&A session of the tool, and I believe Paul will be back for this one.
Thank you so much, Mackenzie. We have some time for questions. Just before, just going to look at the poll results. The first poll was, what do you think is the biggest challenge to security? 58%, not surprisingly, thought credentials, secrets, or data left unprotected in the cloud. 25% said no control over privileged accounts with access to the cloud, and 17% poor cloud architecture design and lack of network hygiene. The second poll, which was which cloud platform do you use? Well, there weren't any great surprises there, or 50%, almost 50-50 really on AWS and Azure. None for Google, which is interesting. 6% others. We'll never know what the others are, but that's what do you think of those results quickly, Mackenzie?
GCP surprises me, but kind of not. Azure is the one that we're seeing a lot come up. Kind of AWS was the standard, but more and more and more we're seeing Azure become a really big competitor in that space, especially with some of their tools. Azure Pipelines and Azure DevOps is the kind of their Git GitHub competitor, and we're seeing a lot of big companies use that.
Yeah, I think it's looking like a two-way, like in many things in life. It's like iOS versus Android. We're probably seeing the same kind of split.
Yeah.
I mean, one thing's for sure, neither of those are ever going to acquire each other. So I think we're guaranteed at least two different cloud structures for the future. we do have, as I said, we've got a couple of questions. So they're a bit long, but what are your this is to you, Mackenzie. What are your recommendations for an organization looking to implement secrets management with centralized storage? What should they start with first? So I guess that's a
Yeah, I mean,
very
that's
open question, but
well, I'll give an open answer. No, yeah, look, that's a great question. When starting from zero, there's a lot of avenues that you can go for in centralized secrets management. So for me, one of the most important elements is you need to understand your problem that you have in your organization before you make any significant moves forwards. What I mean by that is kind of gaining visibility into the areas that you're suffering from. Where are your secrets being leaked? Where are they kind of visible? At what process in your current setup are they being bypassed? And these aren't easy things to kind of find the answer to. But if you don't find the answer to them and you just try and buy expensive tooling and other areas to try and plug those holes, you're not going to implement an effective model to be able to actually combat those sorts of things. What are the secrets that are being exposed? What teams are exposing them? Where in the software development lifecycle or where in the deployment lifecycle are they being exposed? Are they in my source control? Are they in my configuration files? Start there, and then you're going to be able to figure out where to move forward to next, because there's no point, in my opinion, that if you're at level 0, level 1, or level 2, that you should aim for level 4 immediately. You need to kind of implement this gradually, because otherwise, if you do things like if you start finding secrets and blocking developers from access, you're going to cause all these disruptions. So before you're deciding your centralized model, find out where you need to take action. So that would be my open-ended answer to that open-ended question.
Okay. All right. We are running out of time, but actually, I just thank Andrew Marshall, who has commented, more snark than question, AWS versus Azure. You're not expecting this competition to go the way of VHS versus Betamax. I guess he's inferring there that AWS is the Betamax in this case and Microsoft the VHS, but no, personally, I think that one will not defeat the other. Let's have just one more question. Again, for you, Mackenzie, what pitfalls should security teams look for when getting developer buy-in for secrets detection and remediation?
It's really important to kind of get everyone on board with your strategies, particularly developers, but often they don't understand the severity of this. So before you implement tools that are going to block workflows or create additional steps, you need to make sure that your developers, your employees are on board with understanding the criticality of this and actually why you're doing it. We're implementing this system because we have thousands of secrets on our networks, on our source control. This is a big security risk, and here is how we're going to do it. And then always involving the developer, because you need their help, and you need to let them know that they need to be part of this process too, and having those those controls where possible. I always say don't try and block people in their workflows from that, because you're going to create frustration and anger, and that's why it's important to kind of move through the levels, because if you're going to implement blocking checks or areas like that in your secrets management strategy, then you need to already be at a higher maturity level if you're not going to just annoy all your developers and then they're going to bypass everything, right? When engineers, when DevOps and SRE or developers or anyone else is annoyed by processes, trust me, they'll find a way to bypass it. So I think that's the kind of pitfall when you're looking for developer buy-in. Make sure they're involved in the process, they're aware, and that you're not blocking them, but you're moving towards a maturity model together.
Okay, well, right out of time, I'm afraid, Mackenzie. Just quickly, someone's asked, can we get a copy of the slide deck? Yes, of course, that will be available as soon as possible. Both slides, actually, slide decks on the KuppingerCole website. There were a couple of questions that didn't get answered, but we'll forward those on to Mackenzie, and he'll reply separately, if that's okay with you, Mackenzie.
Absolutely.
Yeah. In the meantime, let me just thank you all very much for listening, being with us today. Thanks especially to Mackenzie for that excellent presentation. And as I said, if you do have any questions, follow-ups, you can email me at pf@KuppingerCole.com. We'll do our best to answer your questions. But in the meantime, thank you again and goodbye.